All right, so what we have here is another differential equation where we have total differential equals 0. So of course that only works when the equation itself is exact, so we have to first test that. And remember that we call this m, and we call this n, and we know it's exact if m sub y is equal to n sub x. In other words, the partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. So we first check that. So I'm going to first write m as 2x times y to the negative 1. So then my is negative 2x times y to the negative 2. So n is, and we could write that also as negative 2x over y squared. That's just a style preference there. So n is equal to 1 over y squared minus x squared over y squared, which could be thought of as y to the negative 2 minus x squared times y to the negative 2. And then nx, well, the first term goes away because that's a constant, right? And then the second term, derivative of x squared, is 2x times y to the negative 2, which is negative 2xy to the negative 2. So yes, this equation is exact, which means that there is some parent function that created these differentials. So how do we get there? We're going to integrate both of them. So we know that f is equal to the integral of 2x over y with respect to x, and it's also equal to the integral of 1 minus x squared over y squared with respect to y. So those are supposed to be equal. So let's see here. So the antiderivative of 2x over y dx, now the y is constant, which means that this is just x squared over y, but then the most generalized constant would be some function of y. Okay, because when you differentiate a function of y with respect to x, we're talking about partial derivatives here, it would be 0, which means it would drop out. Now for the second one. So I'm going to have to break this up a little bit here. So I'm going to have 1 over y squared minus x squared over y squared. And that's dy. Well, looking at that, so we know that the antiderivative of 1 over y squared is negative 1 over y. So this is going to be negative 1 over y plus x squared over y, because there's already a minus sign out front, and plus some general function of x. So now looking at these two expressions, these are both our function f. So I'm going to cross out the ones that appear in both, which is the x squared over y here. And what this is telling me is that f of y is negative 1 over y, and g of x is essentially 0. Now I'm calling that 0 now because we know that c comes up in our final solution. Okay, so this means that our solution, f of xy, is equal to x squared over y minus 1 over y, and the solution is of the form f of xy equals c, so it's equal to some constant. And we could also write this as x squared minus 1 over y equals c. And that means any function with that form, pick any constant you want to, will be a solution to that differential equation. So hopefully that helps you, hopefully that makes sense, and thanks for watching.